Hello, how are you? Hopefully you all are fine. Again with me, Sir Kaidir, in Physics Form 4. Alright, so today we are going to continue our lesson, Chapter 2, Subtopic 2.4, that is Momentum. Alright, so focus on this video, watch carefully. Alright, so in this video, in this subtopic, you need to learn about you need to understand about the definition of momentum and the type of momentum, right? First of all, we need to define the momentum. So momentum is defined as the product of mass and velocity. The product there means multiplication. You need to multiply mass and velocity to get the momentum, right? Uh, Look at the formula. Momentum is equal to mass time velocity, or we can write as P. P is referring to the momentum, right? Equal to mv. M is stand for mass, v is velocity, right? Point number 3, momentum is a vector quantity. Vector quantity means you need to consider the magnitude and the direction. Alright, so point number 4, the SI unit of momentum is kilogram meter per second, or you can write as Newton second. This is also unit for momentum. So what is the principle of conservation of momentum? So this is the famous question. So the total momentum in a closed system of object is constant. Constant means there is no other external force react to the system. Okay. The total momentum before the collision is equal. Okay, but the momentum before the collision is equal to the total momentum after the collision if no external force acts on the system. Okay, make sure there is no external force act on the system, then we can call it as conservation of momentum. The momentum is conserved. Alright, so there are two types of collision here. The first one is elastic collision, and the second one is inelastic collision. So look at the elastic collision first. Okay, so elastic collision, both objects move independently at their respective velocities after the collision. Okay, move independently here at their respective velocities after the collision. Let's say the blue car collide with the red car. At first, the red car is at stationary. Okay, means they are stopped. Okay, the blue car moving and then collide with the red car. And then what happened after collision is the blue car still moving and the red car also move. Okay, they are collide and then move separately. This one. Okay, this is the red car, and this is the blue car. When the blue car collide with the red car, okay, and then they are moving separately. Okay, so what happened? Momentum is conserved. Okay, so conserved means we can refer to this principle. The momentum before collision is equal to momentum after collision. The kinetic energy is conserved and the total energy is conserved, and we can use this formula, okay, when there are calculation question. Okay, m1 equal to u1, so m1 times u1 refer to the momentum because mass times velocity, so this is refer to the blue car. m2 u2, mass time initial velocity, referring to the red car, is equal, means the total momentum before collision should equal to total momentum after collision. So this one is referring to the blue car, and this one is referring to the red car. Alright? So what is inelastic collision? So the two objects combine and move together with a common velocity after the collision. So this is the differences between the elastic collision. So this question is like this. Okay, this one is red car and this one is blue car. The blue car collide with the red car. Okay, and then they are moving together. All right, they are moving together. Okay, this is differences between the elastic collision. Elastic collision, when the blue car collide with the red car, they are moving separately. But in elastic collision, when the blue car collide with the red car, they are combined together, move together. Okay, right. So the momentum is conserved, kinetic energy is not conserved. Okay, the kinetic energy is not conserved and the total energy is conserved. So we can refer to this formula. Okay, m1 times u1 plus m2 times u2 equal to m1 plus m2 times v2. So here, because they are combined together, right? So we can plus the mass, and the velocity we calculate as 1. Okay, because they are combined. Okay? Alright. So let's look at this mind map. Okay, I think the differences between the elastic collision and inelastic collision. So the similarities between elastic collision and inelastic collision is the momentum is conserved. Okay, the momentum is conserved and the total energy is conserved. So the differences is the elastic collision, both objects independently at their respective velocity after the collision. So move independently, tidak melekat. And the kinetic energy is conserved. In elastic collision, the two objects combine and move together with common velocity after the collision. Okay, combine together. After the collision, then they are moving together. Okay, and the kinetic energy is not conserved. So you can see the similarities and the differences here. Okay, so the last part for the momentum is about explosion. Okay, so what is explosion? Let's say you imagine the rocket moving upward, right? At first the rocket is at stationary. Okay, and then the rocket is moving upward. When the gas exhaust boosts the rocket to the upward. Okay, this situation we call it as momentum and explosion lah. Alright, so what is explosion? Before explosion, both objects stick together and at rest, means not move. After explosion, both objects move at opposite direction. Okay, look at here. First they are at rest. Okay, before explosion, and then after explosion, the blue car moved to the left, and the red car is moved to the right. So this is, we call it as explosion. So the formula is m1 times v1 equal to m2 times v2. Why there is no mu1 and mu2? Because the initial velocity here is 0. So no need to consider the initial velocity, right? So before explosion, both objects stick together and at rest. After explosion, both objects move at opposite direction. So the total momentum before explosion is 0 because they are at rest. Okay, and the total momentum after explosion is this one, m1 times v1 plus m2 times v2. So from the law of conservation of momentum, okay, the law of conservation of momentum, this law you refer to this one lah. Okay, this is the law. Okay, this is the law of principal conservation of momentum. Okay, total momentum before explosion is equal to total momentum after explosion. So total momentum before explosion is 0, right? Because they are at rest. And after explosion is m1 v1 plus m2 v2. So you can transfer any of this m1 v1 to the left or m2 v2 to the left, any which one lah, right? So the negative sign means opposite direction. Okay, because this is vector quantity, right? Okay, to make you understand about this subtopic, let's try this question. Okay, before that, remember we have learned about elastic collision. Okay, the formula is m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. That's it. That's refer to the in elastic collision. In elastic collision means move together, melekat. The formula is m1 u1 plus m2 u2 equal to m1 plus m2 times v. Alright, and the explosion, this one, m1 v1 equal to negative m2 v2. Right, so let's check the exercise. A trolley A of mass 3 kg is moving with velocity 2 meter per second and collides with another stationary trolley B. So the trolley B is stationary. After the collision, trolley A move with velocity 0.4 meter per second. If the collision is elastic, okay, calculate the momentum of trolley B after collision. So calculate the momentum. So we need to find the momentum. Okay, how to solve this? Make sure the first step you need to write the formula. So this is elastic collision, already stated in the question. So the formula is m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So remember, m1 u1, this is momentum. This is also momentum. Momentum before collision for A. This one is momentum before collision for B, mv. This one is momentum after the collision and momentum after the collision for B. So now the question asks calculate the momentum of trolley B. So you have the information. So just substitute to the formula. So a trolley A of mass 3 kg. So this means here is 3. Initial velocity 2. Okay, plus and collide with another stationary trolley B. So the question didn't give us the mass, but it gives the initial velocity, that is 0. Right? Because B is at stationary. So M1 3 V1 to remove, okay, 0.4 plus m2 v2. There is no mass because the question didn't give us, and the velocity also the question didn't give us. So the question asks about the momentum of trolley B. That's mean we need to find is what? Momentum of trolley B after collision. So here is after. So just calculate 3 times 2 is 6. 6. M2 times 0, of course 0, right? Any other number times with 0 will get 0. So 3 times 0.4, 3 times 0.4 will get 1.2 plus, so M2 V2 we simplify as PB, right? The momentum of trolley B. So to find PB, just bring 1.2 to the left. So 6 minus 1.2. So PB is equal to 6 minus 1.2 is equal to 4.8. 4.8 kilogram meter per second. So check the answer. Yes, the answer is correct. Okay, the answer is here. Okay, this one. Okay, all right. So easy lah. Okay, make sure you write the formula first. Okay, first when you read the question, you recognize either the question is referred to the elastic collision, inelastic collision, or explosion. Then you write the formula. You take out the information, then substitute to the formula. Alright. Okay, now we continue to the second question. So there are 3 questions here. A car travels with velocity 32 meter per second collides head-on with a lorry, which moving at a velocity of 17 meter per second. If the masses of the car and the lorry are 1000 kg and 5500 kg respectively, calculate the momentum of the car before collision. Alright. So momentum of the car only. Okay. So just write P car, the momentum of car, M car, V car. Okay. So you need to find this one, momentum of car. Just substitute the value. The mass of the car is 1200 times the velocity of the car before collision, 32. So when you calculate, just press your calculator, times 32. So the answer is 38,400 kilogram meter per second. So same as the answer here. Okay, actually dia sudah tukar pergi not general form, what we call it as, teacher forgot lah. Means how to get 3.84 times 10 negative 4 means 1, 2, 3, 4. So the decimal point is there. 3.84 times 10 power of 4. Why power of 4? Because you move 4 times. Okay, and then you write the unit. You answer like this pun boleh, like this pun boleh. Alright. Okay. The second question, calculate the total momentum. So the total momentum here. Okay. So remember, the laws of principal conservation of momentum, the momentum before the collision is equal to the momentum after the collision. That means we just need to find this momentum, because momentum here is also the same to here. But in this situation, after the collision, there is not enough information, because we don't have V. Here we have enough information. Alright, so just write, this is a inelastic collision, right? M1 U1 plus M2 U2. So just substitute. M1 is 1000 times the initial velocity is 32 plus M2, the mass of the lorry is 5500, and look at the direction here. Okay, look at the direction of lorry to the left, right? That means you need to put negative here. Remember, this is a vector quantity, so you need to consider the direction. Okay, so 1000 times 32, so already calculated, plus 5000 times negative 17, so you will get plus negative 93,500. So when you calculate, you will get negative 55,100, okay, kilogram meter per second. So the negative signs mean the direction. So correct. This is correct. The answer here is correct. Okay. So now question C. Alright. The final velocity of the two vehicles after collision if the collision is inelastic. So actually we already calculate the momentum tadi kan. Negative 55,000. Okay. This is the momentum before the collision. So according to the principle of conservation of momentum, the momentum before collision is equal to the after collision. So the formula is M1 plus M2 V. So we need to find the velocity. Okay. M1 plus M2 1000 and 200 plus 5500 times V. So V negative 55,100 divided by 6,700. So you will get V equal to negative 8.22 meter per second. So same as this answer. Alright. So actually easy. Alright. Easy when you understand the question and the situation. Okay. Next question, next example. A bullet of mass 5 gram with a velocity of 150 meter per second hits a 1.5 kilogram of stationary ice cube on a smooth surface. The bullet passes through the ice cube and travels with velocity 70 meter per second. What is the resulting velocity of the ice cube? So first step, you need to recognize this is elastic collision, inelastic, or collision or explosion. Okay, so the bullet passes through. So first of all, this bullet uh, okay, this bullet 5 gram move with a velocity of 150. So the velocity is 150. Hits a 1.5 kilogram of ice cube. So this ice cube is 1.5 kilogram on a smooth surface. Okay, actually this is the first situation. The ice cube is at stationary. So this is initial velocity for the bullet. This is the initial velocity of the ice cube, u. So 0. Okay, 1.5 kilogram of stationary ice cube. That's why here is 0. The bullet passes through the ice cube. So the bullet passes through the ice cube and travels with 70 meter per second. First, the ice cube is 1.5 kilogram. The final velocity we don't know. This one, the bullet 5 gram, and the final velocity is 70. So the question asks, what is the resulting velocity of the ice cube? So logically, what type of momentum here? Elastic, inelastic, or explosion? For sure, this is a elastic collision, because logically, kalau this bullet, kalau dia tembak ice and passes through, right? Of course, this ice also moving, kan? So moving, but moving separately with the bullet. Okay, moving separately. They are not moving together. So that means this is a elastic collision. So you need to calculate m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So just substitute the value. Make sure 5 gram you change to SI unit. Gram, the SI unit for gram is kilogram. So 5 gram, when you change to the kilogram, 0.005 kilogram times the initial velocity is 150 plus m2, the mass is 1.5 times 0, because at stationary. So m1 is 0.005 times 70 plus m2 1.5 times v2, the final velocity for the ice, right? So when you calculate 0.005 times 150, so here you will get 0.75 plus 1.5 times 0, so it's 0, no need to write. So directly teacher ambil this one is equal to 0.005 times 70, so you will get 0.35 plus 1.5 v2. So when you manipulate this formula, you will get 0.35 you bring to the left, so you will get 0.4 equal to 1.5 v2. So v2, continue here, okay? v2 is equal to 0.4 over 1.5. Then just press the calculator. 0.4 divided by 1.5. So you will get 0.27 meter per second. So check the answer. Yes, correct. Okay, all right. Let's check the last question. A rifle's out a bullet of mass 10 gram at a velocity of 300 meter per second. If the mass of the rifle is 7.5 kilogram, calculate the recoil speed of the rifle. So, as usual, you need to recognize. Okay, you need to identify either this is elastic collision, inelastic collision, or explosion. Of course, rifle, of course, this is explosion because remember, explosion there is no this one. All this the situation before explosion is at rest. Okay, this is a rifle, and in this rifle have a bullet. So at first they are at stationary. Okay, when you fire, then we got the momentum after the explosion. Okay, before explosion is 0. Okay, so the formula for this situation is m1 0 equal to m1 v1 plus m2 v2. Alright, so if the mass of the rifle is 7.5 kilogram, calculate the recoil speed of the rifle. So speed means velocity lah. So m1 refer to the bullet. So the mass is 0.01. Okay, so here is 0. So the velocity for the bullet is 300 plus the mass for the rifle 7.5 times V2, because this is we need to find. So 0.001 times 300, 0.01 times 300, we get 3. Okay, 3. So plus 7.5 V2. So we need to find V2. So 3 you bring to the left, negative 3 plus, oh no, not plus, 7.5 V2. So continue here. V2 is equal to, we bring to the left hand. So negative 3 divided by negative 7.5. So you will get negative 3 divided by 7.5. So you will get negative 0.4 meter per second. So same as the answer. Why negative? Negative 0.4 meter per second is referred to the velocity of the rifle. Let's say this is a rifle. When you shoot, the bullet will come out to the front, kan? Move forward, and then the rifle you shoot, right? You are moving backward, kan? That's why the velocity of the rifle is negative, because when you shoot, the rifle will moving backward. Boom, the bullet going pergi depan, and the rifle moving backward. Okay, alright, that's all for today. I will give you exercise later. Hopefully you all can understand, and try to watch this video, repeat and repeat when you don't understand, or you can ask me privately. So that's all for today. Bye bye.